welcome to a live recording with regards to how to deal with this formula here. All right. Once again, this formula here is called Snell's Law. He was a famous scientist who was able to determine and predict the relationship between theta I and theta R. So as long as you know three things of your givens, for example, you know your theta I, you know your two refractive indices of your material, you can figure this out. Okay, you can solve for theta R. What exactly should that number be? Exactly down to the nearest tenth of a degree. All right. But to accomplish that, you need to know how to rearrange this equation here. And that's what we're going to do first. We're going to go through the exercise of rearranging this equation. Once again, as a reminder, this equation has four variables. All right. So you have Ni as a variable, theta I as an angle as a variable, Nr, and theta R. All right. So we're going to go through the exercise of isolating for each of these variables. And again, make sure you practice away at this. Okay. Because when it comes to test time, I'm just giving you the formula as is, and it's up to you to know how to rearrange the equation in the four different ways. We'll start off by rearranging for Ni. Okay, so how do we do that? First thing we're going to do is we're going to write out the equation as is. So Ni times sine theta I is equal to N subscript R times sine theta R. If you're wondering what sine is, it's a button that's available on your scientific calculator. If you look right over here, there is a sine button. You'll learn in math class what sine is. So if you have math second semester, I guess you have to be patient for that. But if you're learning it right now, how many of you guys are actually learning trig right now? No, haven't gotten there. Okay, so at some point you will get to that button. Okay, today I'll just show you how to use the button, and then in math class you'll learn why that button exists. Okay. So, Wilbur Snell was able to predict the formula based upon a special button on your scientific calculator. Okay, so we're going to isolate for N theta I, or N subscript I. All right, we see that N subscript I is multiplied by sine theta I. So whenever you're trying to solve these problems, if you're trying to isolate for something, to get rid of something, you need to do the opposite function. So if Ni is multiplied by sine theta I, to get rid of this, you need to divide everybody on both sides by the same mess. You need to divide it by sine theta I. One thing just to point out, guys, is that sine theta I, you can imagine it as if there were brackets around it. Okay? Treat it as if it was one object. Okay? So you need to divide both sides by that one physical object. I know it's tempting to try to cross out the signs here, but you cannot cross them out. Okay? Because this is a trigonometric function. Okay, they are attached together. They're united, and you cannot break them apart. Okay, they have to be associated with each other. But what can be divided out are these two. I gave you guys an example earlier where, for example, if you divide 5 by 5, you get 1. If you divide 7 by 7, you get 1. If you divide x by x, you get 1. So if you divide sine of theta subscript I by the sine of theta subscript I, as these two are identical, they will also go to 1. So they will divide each other out. So your final statement is that Ni is equal to N subscript R times sine theta R all over sine theta I. Okay. Next example, we're going to isolate for theta I. Okay. Isolate for theta I. We'll start off by writing out the formula as is. So Ni times sine theta I is equal to N subscript R times sine theta R. I'm going to highlight, just as a reminder, what we're trying to solve for. We're trying to solve for theta I. Just like in the previous example, you'll see that sine theta I is currently glued to N subscript I by multiplication sign. Okay, so you have to do the exact opposite of multiply, which is to divide. And that's why we're going to divide everybody on both sides by N subscript I. We're doing that so that these two will divide each other out and go to 1. All right, so we end up with sine theta I is equal to N subscript R times sine theta R. Okay, So what to do next? How do we exactly get rid of this sign over here? Well, let me give you another side example, all right? If you have x squared is equal to 9, how do you get rid of the squared? You do the opposite, which is square root. So you square root both sides, and eventually you're going to get x is equal to plus minus 3. Okay? So you're doing the opposite arithmetic function. And that's what you need to do to get rid of sign. You need to do the exact opposite function. Now, I'm assuming that nobody here knows the exact opposite function. So what you do is you just look at your calculator. Your calculator is already rigged that way. Because if you look at the sign button and you look directly above it, you'll see that directly above the sign button, there's sign to the negative 1. All right. So that is the opposite operator to sign. And that's what we're going to do next. Okay. Let me just erase this out just so I can get more space. So I have NR times sine theta R. So to get rid of the sign on the left-hand side, we need to do the exact opposite operation, just like what we saw over here. Okay. So the opposite operation of sine is sine to the negative 1. And just like in our examples from before, whatever you do on the left-hand side, you must do with everybody on the right-hand side. Okay, and since sine and sine to the negative 1 are opposite operations, they will eliminate each other out. So at the end of the day, you're left with theta I is equal to sine to the negative 1 nr times, whoops, I forgot something, nr times sine theta r, close bracket, oh, inside the bracket, sorry, divided by ni. Let me clean that up, because I forgot to copy something on my way through. There you go. Okay. You must do with everybody on the right-hand side. And that's why I'm placing the brackets around all this stuff over here. Okay. So sine inverse, everything you see on the right-hand side. So plot it out as a nice, clean formula. There it is, written out nice and clean. Just to let you know, I am recording this right now, so whatever you missed out on, you can watch this afterwards. Yes, I will cast it afterwards. Right? It's a live recording, so maybe you want to keep your speeches to a minimum because it's going to be permanent. Okay. So far, so good, guys? Okay, now let's do the other two. Okay, how do we isolate for the right-hand side? I'm going to erase all this stuff right now because I need the space for it. Just a raise of hands if anyone needs me to pause for a second. Okay, there's quite a few. Sorry about that. I'll pause for a second while you guys are jotting that down. All right, can I erase this stuff right now? Again, it has been recorded. Okay, this stuff is recorded right online, or will be posted online. Okay, so let me just erase this stuff right now, and let's isolate for NR. Okay? So we're going to take the formula, rewrite it one more time. Ni times sine theta I is equal to NR times sine theta R. I'll highlight what our objective is. We're trying to solve for the NR on the right-hand side. Before we get there, let me give you another analogy. And the analogy is x equals 1 versus 1 equals x. Right? Intuitively in your head, do they both mean the same thing? Yeah. Now, there's one that's grammatically correct. All right. This is grammatically correct. Okay. You always place your variable on the left-hand side. Okay. So the variable we're looking for is always on the left-hand side because we want to create an international standard. Right. With standards, others can follow along as well. So that's why this is the preferred standard. You always isolate for the variable you're looking for on the left-hand side. That's correct. This one here, even though the world may understand it somewhat, it's grammatically incorrect. And if you're a computer programmer, you'll notice if you do it that way, your code will not run. And that's what I mean by how we need to create international standards. So that's what I'm going to do next. I'm just going to do a quick swap-a-rooney. So I'm going to take everybody and I'm going to swap them all around. So logically, they will make sense, and we're aiming for grammatically correct as well. So I'm just doing a quick swap-a-rooney. Maybe I'll just keep the arrows there. And now I have NR times sine theta subscript R is equal to NI times sine theta I. Here it is, just quickly rearranged. Because at the end of the day, when we have our final formula, we need to isolate for NR on the left-hand side to be grammatically correct. Okay, at this stage over here, we see that NR is being multiplied by the stuff in the circle. So to get rid of it, we need to do the opposite of multiply, which is divide. And that's why we're going to divide both sides by sine theta r. Okay, now on the right-hand side, sine theta I and sine theta R, these are two different variables, right? Remember that this is on one side of the boundary and this is on the other side of the boundary. So these are two different things. They cannot cancel each other out. Okay, so you have to leave that alone. What you can cancel out, however, is sine theta R. These two are clones of each other and they will divide each other out to 1. Once again, as a reminder, if, 9 divided by 9 is equal to 1 and x divided by x is equal to 1, then something that looks crazy like this divided by the same exact clone that looks identical to it will also equal 1. And that's how we rearrange for this equation here. NR is equal to NI times sine theta I all over sine theta R. And that's how it is rearranged at the top. Okay. Again, to be grammatically correct, the variable you're looking for should always be on the left-hand side. All right, now let's solve for theta r. Okay, so now we're solving for this last variable here. Starting all over again, we're going to rewrite the entire equation. So ni times sine theta I is equal to n subscript r times sine theta r. I'm going to highlight to remind you what our objective is. You'll see that our objective is on the right-hand side, but to be grammatically correct, this needs to be placed on the left-hand side. So we're going to use the same hack as before. We're just going to do a quick swap-a-rooney. Okay? If we know that 54 is equal to x, then yeah, surely x is also equal to 54. Okay? So that's why we can get away with swapping it like this. So n subscript r times sine theta r is equal to n subscript I times sine theta I. As a reminder, our objective is to solve for theta r. Currently, theta r is inside sine, and it's also being multiplied by nr. So the only thing we can get rid of right now is something on the far end, which is nr. To do that, if it's multiplied at the beginning, we need to divide both sides entire by n subscript r. Okay, that way these two divide each other out. So in our next line of rearranging, we have sine theta r is equal to ni sine theta I all over n subscript r. Lastly, to get rid of sine theta r, we need to do the same thing on both sides. Okay, so if the left-hand side, to solve for r, it has been sine, we have to do the opposite of sine. Okay? And the opposite of sine is sine to the -1. At least that's how it's written on calculators. Right? It's known as the arc sine or the inverse sine, and that's how you eliminate these two. But just like in all our other examples, you'll notice that anytime that you want to get rid of stuff, you must do the same thing on both sides. So from the left-hand side, we get rid of the sign with this crazy-looking thing. We need to rewrite the same exact thing on the right-hand side as well. Okay, because we need to do the operation on both sides to isolate and solve. Just like in grade 9 and grade 10 math. All right, that hasn't changed. So as our final statement, when we isolate for theta r is equal to the sine inverse of ni times sine theta I all over n subscript r. And here it is. Okay, so once again, on the test, I will give you this formula. This formula will be given. And it is your task and your objective to be able to take the formula and rearrange it. All right. And through practice, that's how you excel at being able to rearrange this. So one thing for homework tonight, what I'd like you to do is just take out a blank sheet of paper, write this formula down at the top. Okay, so write that right at the top. For the remainder of the sheet of paper, solve for Ni, theta I, Nr, and theta R. And once you're done rearranging it, make sure that it matches up with the ideal answer. Okay. Now, when it comes to test time, do you need to show all this work over here? Some people get really good at this, and they can rearrange in their head. All right. In fact, I've practiced at this enough times that I can mentally rearrange that in my head and just jump to this answer. Okay. So if you're able to do that, that's fine with me. Okay. So in other words, when you work out your work and you know that you're trying to solve for NR, and you show this as your formula to solve for it because you know how to rearrange in your head, I'm okay with that. Okay, guys? Once again, this has been pre-recorded, so if you are having troubles in trying to rearrange it, please rewatch the video again, and I hope I didn't make any mistakes along the way. Okay? Because this is the process of rearranging it, and it's the same thing over and over again. Okay, next, I'd like to go through some mathematical problems. All right, so how do you solve problems now knowing that this formula can be used as a tool? Anyone else still need this before we move on? Okay, and this is where the heart of where physics lies, really. All right, the whole purpose of physics is to be able to predict outcomes. So if you're given a scenario and you know that it can be modeled by this mathematical formula, so this formula can tell you what the outcome can be, you use it to predict your outcomes. That's what we do all the time these days before we build anything. All right, so before you even build your first car, before you build a bridge, before you make a building, there are structural engineers that sit down and do these calculations so they can figure out, oh, this is what's going to happen if I had it set up this way. Now, I know this only relates to light, but physics also applies to physical objects as well. All right. You may have heard of mechanical advantage and torque back in grade 7 and 8. All right. We don't really focus much on those details next year, but it's of that idea. All right. By knowing that you can use an advantage, so you can use science to your advantage, you can have mathematical formulas to help you predict what the outcome will be. So here's one example. Okay. Calculate the angle of refraction for an instant ray of light given these criteria. And for the visual learners, this is what I'm talking about. Let's say that you have a cup of water, just like how I did with my demonstration earlier. And because you were bored, you decide to shine a laser light into the water. The question is, how does the light bend when it's inside the water now? Where will it bend towards? Okay, before we get to our final mathematical answer, let's go back to the logic that we learned earlier. All right? So we're going between two separate materials right now. We're going from air, which has a refractive index of 1.0003, and we're going into water, which has a refractive index of 1.33. Okay. An arrow is pointing that we're going from this medium to this medium. We're going from less to more. And as we go from less to more, the ray of light will bend towards the normal. Good. Okay. Now, the reason why I'm showing you this right now is that I want you to know approximately what the final answer should be. So if the initial angle, if the initial angle was at 30 degrees, we know that our final answer has to be what? Less than 30 degrees. Does that make sense? Okay, so you know that your answer is correct if your final answer is less than 30 degrees. Because if you type in your calculator and you end up getting 47, you know something went wrong. Okay, because from less to more, it should bend towards normal. You should get an answer less than 30 degrees. So let's work that out right now. Now, I do have this all PowerPointed out, all right, and it's all animated out, but I think most of us follow better if I just do everything wrong. Okay, so I'll go through everything real time as if I was answering this on a sheet of paper. Okay, maybe I'll leave this part up here as a reminder. Anytime you're solving any of these problems, these word problems, make sure you follow this structure over here. It's kind of like in English class where there's a hamburger paragraph. It's a way of writing in such a way that others will follow along linearly as well. All right? So let's follow this international standard. First thing we need to do is tell the reader, what do we know so far? Okay, so we start off with our givens. Okay, so we see that there's 30, 1.003, and 1.33. Let's give it meaning. Okay, we know that the 30 degrees is the ray of light going into the water. It's known as your theta I. So your theta I is equal to your 30.0 degrees. Yes, please include symbol. I'll just write it in red, just as a reminder. I know it seems rather silly. Well, why are you writing down that little circle? Why does that make a world of a difference? And it's because angles are not just limited to 360 degrees as a full circle. Okay? In math class, in elementary school, you might have learned that, yeah, if you go full circle, it's 360 degrees, but why 360? It's a very strange number, isn't it? Why didn't they just use the number 100? All right, since it seems cleaner. In fact, there are some people that tried to make it metric, and they went from 0, 100, 200, 300, and 400 for a full circle. Okay? But there are other numbering systems that exist, and that's why you need to put the circle over here, because that reminds you that it's 30 out of 360 of the full rotation. So it's important to include the degree symbol. Okay? Because if you erase it, someone might accidentally see it as a different measurement, and it's called radians if you're curious. All right? There's another way to measure angles, and it's measured in radians, and that's without the degree symbol. Okay, so we got our 30 degrees so far. Next thing is that we're going from air into water. Okay, now with the letters of I and R, its whole purpose is to denote, this part of this problem and this part of the problem. Okay, I is for where the light is coming from, and it is coming from air. So we know that our N of air is our incident angle. Okay, so we won't call this N of A because that's not relative to our mathematical problem. Our air is our Ni, and that is at 1.0003. Okay, because we're going from air into water. So our theta I is equal to 30 degrees. Our Ni is equal to 1.003. And you need one more piece of the puzzle to solve this problem. Okay, again, the formula for Snell's law, which once again is Ni times sine theta I is equal to Nr times sine theta R. There are 4 variables. So the only way that's possible to solve this problem is if you have at least 3 out of the 4. And luckily we do have 3 out of the 4 because the refractive index in water is equal to 1.33. Once again, this is the new medium, so we replace the letter W with R. So we have N subscript R is equal to 1.33. So there are our givens, okay? Theta I is 30 degrees because the story tells you, calculate the angular refraction of an incident ray of light at 30 degrees from air into water. Okay? So once your givens are laid out perfectly, you can move on to the next one, which is your require. You could write down the word require, but internationally, we know that a question mark tells the reader this is what we're trying to look for. And yes, this is what we're trying to look for right here, theta R. Okay, guys, so you don't have to write down require. I mean, if you're tempted to, by all means, you can write down the word require, and I'm okay with that. Okay, if you want to write it down because of habit, by all means, but I'm just letting you know, you can write it out like this, and I'm totally okay with it. One thing I do want to point out, guys, is that when you state your givens, please list it out like this. List it out like a shopping list, okay? Please don't write it out horizontally. I know that you can save more space this way, but it's harder to read. Line it up in such a way that the equal signs are all lined up vertically, okay? Try to line up your equal signs vertically because that makes it more appealing to the eye and it's easier for others to follow. Okay? Normally, when we solve these problems, we write it in kind of like in this configuration, like so. So in other words, we write down to the first column. If we run out of space, we go to the top, we write down the next column, we run out of space, and we just keep on going like so. Okay, so that's how we write it out. I'm going to erase this part now, okay? But as a reminder, yes, you need to have the degree symbol in there. It is important. Okay, so we are given, require, the next one, which is analysis. This is showing the reader what formula you're going to use to solve for this. Okay, once again, I'm going to rearrange it for you in real time. So you have Ni times sine theta I is equal to N subscript R times sine theta R. So we're trying to solve for theta R. Right? That's what we're trying to solve for. Again, the variable you're trying to solve for needs to be on the left-hand side to be grammatically correct. You could do this at the end. Some people like doing that as a last step, all right? But I like to be proactive and just get those necessary things out of the way. So that's why I'm going to do the swap-rooney at the beginning. NR times sine theta R is equal to Ni times sine theta I. Okay. In fact, I'll tell you my intentions in green. Okay. Once again, we're trying to solve for theta R, and right now it's being obstructed with multiplied by N subscript R. And because it's being multiplied by N subscript R, to get rid of it, we need to do the exact opposite. We need to divide by N subscript R. And whatever we do on the left-hand side, we must do with everybody on the right-hand side. These two NRs will divide each other out. They're going to go to 1. So in our next statement, we're going to have sine theta R is equal to Ni times sine theta I, all divided by N subscript R. Once again, you'll notice on your calculator, to get rid of sine, when you hit the shift button and hit sine again, you're going to see this show up on your screen. Sine -1. Okay. So that's the opposite operation of sine of something. Okay. Once again, whatever you do with the left-hand side, you must do with everybody on the right-hand side. So as our final statement now of this formula completely rearranged, we have theta R is equal to sine to the -1 of Ni times sine theta I all over N subscript R. Okay, and if you're comfortable with just rearranging this right from the beginning, that's fine with me. I'm just showing you guys one more time how I came about rearranging it. Okay, and this is part of your analysis. Your analysis is the formula. Moving on to solve. Solve means to substitute. Sub the values in now. All right. So theta R is equal to sine to the -1 of 1.0003 times the sine of theta I, which is at 30.0 degrees, divided by N subscript R. Whoops, 1.33. Okay, and you need to figure out how to type that into your calculator to get to your final answer. Okay, so we'll pull out our handy dandy notebook. No notebook, but our handy dandy scientific calculator. Here it is. Okay, I hope that you're using a newer generation of the calculator, because if you're using an older generation of the calculator, and unfortunately the iPhone is using the older model, you have to do everything backwards to get to the answer. All right, it's a little bit more counterintuitive, okay, than the newer modern calculators. So what I have here is an emulation of a modern scientific calculator. I mentioned to you what models that I recommend in you purchasing. All right, but really any will do, and hopefully you have one of these forward ones. Okay, so what we're going to do is we're going to write down this entire statement into the scientific calculator. To show sine to the -1, we need to hit the shift button and then hit the sine button. Go ahead, follow along with me. Okay, pull out your scientific calculator that I mentioned to you you need to bring out today. All right, so hit shift sine. I hope you can see that text on your screen. If that text does not show up on your screen, it means you have one of the older calculators and you have to do everything backwards. Okay, and I'll show you afterwards how to solve this using the older system. Okay, I'm going to show you the newer system right now. So the newer system is shift sine button. That gives you sine to the -1. And in the numerator is 1.0003 multiplied by the sine of 30.0. This calculator, because it's so new, it automatically opened brackets for me. If you have a calculator that's about 10 years old, it doesn't include the open bracket automatically. It's okay, you don't have to show it. But if the calculator opens it for you, make sure you close it. Because we're doing the sine of just 30 degrees. Then we're going to divide everything by 1.33. Okay, so if your calculator open brackets for you, make sure you close bracket it. Then we're going to divide by 1.33. Okay, now something else, I don't know if you noticed this calculator open bracketed for me at the beginning as well. And if you didn't do it automatically, I hope you filled in that one, because that's important. Right? We are doing the sine inverse of everything inside the brackets. So sine to the negative 1 of everything here, all divided by 1.33, and then we need to close bracket it. Actually, before we move on, you'll notice that there's a little tiny d on top. I hope that you have d. D is for degrees, and that's what this circle up here is for. If it shows the letters of R or G, make sure you know how to reset your calculator. Okay, because it's not going to calculate it out correctly in that case. Okay, we predicted earlier that if everything is done properly, if you go from less to more, it should bend towards the normal. So the correct answer should be less than 30 degrees. Let me hit the answer key, and if I get less than 30, I probably did it correctly. Did you guys get that answer as well? Good. All right, so that is the answer, 22.09 degrees. Now, if you're wondering, how precisely or how accurately must I show this? Because when you look at the calculator, it's showing an insane number of digits over here. No, you don't need to copy down all the digits. In fact, take a look at what's given to you here, okay? On the first number here, you'll notice that there are 1, 2, 3 physical digits that are shown to you, or 3 significant figures. This one over here has 1, 2, 3, 4, 5 significant figures, and this one has 1, 2, 3. All right. Now, whenever you're doing calculations, if you start off with crude numbers, you know your answer at the end will be crude as well, or approximate. If you have exact numbers at the beginning, your final answer will also be exact. Okay? So really, your final answer will be as good as your measurements. You'll notice that this measurement over here only shows 3 digits. That's why your final answer over here should also be 3 digits as well. Okay? Because this is the most crudest measurements over here. Okay? Just 3 digits. All right, so your final answer should be 22.1 degrees, and you're good to go. Now, if you write down 22.09, I'm going to let it slide. I'm not going to worry too much about it, but I don't want to see anyone writing down this as their final answer. Okay? Because if you write this down, in truth, this is impossible to measure. Go ahead, try this out. Remember, this is degrees. Go and draw for me an angle that's exactly 22.08938684 degrees. And you'll know that humanly it is impossible. Okay? Is it possible to draw at an angle as careful as this? Yeah, I suppose if you bought something as big as this, it is possible. Okay? So this number here is attainable. This is humanly possible. This is humanly impossible. Okay, guys? So just keep that in mind, because in science, we don't care about digits like this. I know in math, they show it like this, but in science, we know that, hey, if your measurements are like this, they're nice and crude, your final answer is going to be crude as well. It's not going to be as accurate or as precise. Okay, guys? So just keep that in mind whenever you're solving these problems. Aside from that, that is it for today's lesson.